We have already discussed different types of the clippers. In this class, we are trying to understand unbiased diode clippers. Unbiased. We are not adding any external battery other than our input. Definitely, we are giving the input. And we are expecting this input signal should be clipped. I am deciding whether I require half cycle, that is negative half cycle, or positive half cycle. So which element I am using for this clipping? I am using the diode. Because I am using the diode, these clippers are called as diode clippers. And because I am not giving any external battery to this diode, we are not connecting any external battery. Here you see, we have not connected any DC battery. So that's why these are unbiased diode clippers. Okay. First we are learning the negative and positive unbiased clippers. See here, when the diode is connected in such a way that we are providing the input signal to the anode. The anode terminal is connected to our input supply. We are giving the sinusoidal signal. You may get the doubt, sir, we have given square waves for the RC differentiator and integrator. Why you are suddenly giving the sinusoidal signal? Because this is a non-linear wave shaping circuit. To understand the linear wave shaping circuits, if we give the sinusoidal signal, output also we will get only sinusoidal. We might not able to understand the circuit function. That's why we have consciously given non-sinusoidal square signal. Here, even if we give the sinusoidal signal to this circuit, the output waveform will change. So we can understand the circuit functioning. That's why we are giving the sinusoidal signal as an input. We have given the sinusoidal signal as an input. And the diode cathode is connected to resistor. Resistor is nothing but the load. Whatever the signal that is appearing here, the resistor with a small attenuation, the signal shape will be same observed across the resistor. That's why for my convenience, for our convenience, we are taking the load as a resistor. And we are taking the output across this resistor. During the positive half cycle, the diode is forward biased. And whatever the supply we are giving, that supply appears across the resistor. This is theoretically when the diode is ideal. But in reality, diode is having 0.7 volts forward voltage drop. If that is a silicon diode, we will use the silicon diodes in the laboratories. If that is a germanium diode, the voltage drop will be 0.3 volts. So this 0.7 volts, even when we are starting with 0.1 volt, there will not be any output across the resistor. The 0.1 volt entire voltage is being consumed by the diode itself. If we give 0.2 volts, the output voltage is 0. 0.5 volts output voltage is 0. 0.8 volts, then the diode starts supplying the voltage to the resistor. Then the diode acts like a closed switch. Then the diode is forward biased. But we are neglecting this forward voltage drop, and ideally we have drawn this waveform. During the positive half cycle, the diode is forward biased. During the negative half cycle, the diode is reverse biased. Reverse biased means it acts like open switch. Whatever the voltage we are giving, no voltage will appear across the resistor. So the output voltage is 0. That's why this type of clipper is called as negative clipper, because it is clipping the negative portion. It is clipping the negative portion. Entire positive portion of the wave is coming. That's why it is called as a negative clipper. But as we already discussed practical scenario, the entire positive waveform will not come out across the resistor, because during the starting 0.1, 2, 3, 4, 5, 6, 7 volts, the diode will take that voltage and it will not supply any voltage to resistor, because this diode is not at forward biased. Neglecting that forward voltage drop, when we are taking the ideal case of the diode, then the entire positive wave will appear across the resistor. The same thing we can even get by using a diode when it is connected in shunt circuit. This is series negative clipper and this is shunt negative clipper. Here we have the clipping element diode is connected in shunt with the load. If we are connecting the diode in series with the load, it is series clipper. If we are connecting the diode in shunt with the load, then it is a shunt clipper. During the positive half cycle, this diode is reverse biased during the positive half cycle. And the entire voltage appear across the resistor. So the positive voltage, whatever the positive voltage we are supplying, we will observe across the resistor. During the negative half cycle, the diode is short circuited. The diode becomes a closed switch. So here during the negative half cycle, it is forward biased. It is reverse bias and it is forward bias. Because it is short circuited, the entire voltage will be grounded and there will be no voltage across the resistor. This is the shunt negative clipper. Unbiased diode shunt negative clipper. And now we are discussing about the positive clipper. This is series clipper. This is shunt clipper. When we are supplying the negative voltage to it, first we will take the positive voltage. During the positive voltage, when we are during the positive half cycle, this diode is reverse biased because we are supplying the negative to the cathode terminal. We are supplying the positive to the cathode terminal. Because the positive supply is connected to the cathode of the diode, this is reverse biased. When the diode is reverse biased, it acts like a open switch and no voltage will appear across the load. We are taking the voltage across the load only. This waveform is not across the diode, but this waveform is across the resistor. During the negative half cycle, this diode is forward biased and the negative waveform is appearing across the resistor. But in practical scenario, as we discussed already, even if we give minus 0.1, the diode is still not at forward biased. So the entire wave will not appear across the load. When we are supplying more than minus 0.7, then only the diode is forward biased. If we are supplying minus 0.8, then the diode is forward biased. If we are supplying minus 0.6, the diode will take that voltage, but it will not give any voltage to the resistor because the diode is still not at forward biased. The voltage drop 0.7 in the practical scenario, that is making the entire negative waveform to not appear across the load. By neglecting that voltage drop, when we are discussing in the ideal case, theoretically, the voltage waveform will be like this. When we are discussing about the shunt clipper, during the positive half cycle, the diode is forward biased and it is short circuited. During the positive half cycle, it is forward biased and there will be no voltage across the resistor. Entire voltage will be grounded. And during the negative half cycle, the diode is open circuited. The diode acts like an open switch. Because it is open switch, the entire voltage appear across the resistor. This is how unbiased negative and positive clipper circuits will work. Means in these circuits, we are using the diode as the clipping element. That's why these are called as diode clippers. Why particularly we are calling as the unbiased? We are not giving any external supply to the diode. That's why these are called as unbiased. Why this is a negative clipper? Negative peak is clipped. Why this is positive clipper? Positive peak is clipped. If both ends are clipped, then those types of clippers are called as double-ended clipper. If we are using both diodes to even clip the positive peak and negative peak, then those types of clippers are called as double-ended clippers.